Okay, I got cut off because the free screencast software that I'm using cuts me off after 10 minutes. I thought I could make it through this explanation, but okay, so we know that the places where the first derivative equals 0, and we know that the first derivative equals 0 when x equals positive or negative 2. So we want to test those points and see what the second derivative is. So when x equals negative 2, the first derivative is 0 and the second derivative is negative. So that tells us that since the second derivative is negative, the graph is concave down. And if it's concave down, then it's going to be a maximum. At x equals 2, the first derivative equals 0, as we know. And the second derivative, if we plug in 2 into the second derivative is greater than 0, is 12. So that means the second derivative is positive. The graph is concave up for positive, which means that we're going to have a minimum. All right, this leads us to our final process for function analysis. So we've got 5 steps. So our 5 steps are going to be to find the first and second derivatives. Then we want to find the critical points of the first and second derivatives. We want to make sign charts for the first and second derivatives. And then we want to find the y values of all of those critical points and end points. And then we're going to write our sentences of explanation. So here's an example. So f of x equals x times e to the 1 over x. We know that x cannot equal 0 since that would be undefined. So we find the first derivative by doing the product rule. Then we factor out e to the 1 over x, and we get this. Next, we find the derivative of this, again, using the product rule. Okay, and then now we're going to simplify this a little bit. Okay, so look at this simplification. We factored out e to the 1 over x and 1 over x squared. We factored both of those out, which left us with negative 1 times 1 minus 1 over x plus 1. And then we can simplify that again, and we get here. Okay, so their second derivative. Now we find the critical points, the places where the first and the second derivative equals 0. So the first derivative equals 0, that's here. So the first derivative, this equals 0 when, let's see, 1 minus 1. So we want this part to be 1, so x equals 1. So that equals 0 when x equals 1. And f prime does not exist when x equals 0, right? Because then we'd have a 0 in the denominator there. For f double prime of x, for a second derivative, it equals 0 nowhere. Okay, because if x equals 0, we've got a 0 in the denominator here, so it does not exist. And we know that e to the 1 over x is never going to equal 0. So now we've got our critical points, and we are going to make our sign chart. So this is a problem where you could make your sign chart with a calculator. Okay, you could use a calculator to plug in some of these numbers, make a table, use that to help you with this sign chart. So our first derivative is positive on the interval negative infinity to 0. It's negative from 0 to 1, and then it's positive again here. And we can tell that the function is concave down from negative infinity to 0. It's concave up from 0 to positive infinity. And now we're going to find our y values. Okay, so we know that at 0, f doesn't exist, right? When x equals 0, f doesn't exist. When x equals 1, f of 1 is e. Okay, so that might tell us something. And our last step is going to be to write our sentences. All right, so our first sentence, f of x is increasing on negative infinity to 0 and on 1 to positive infinity because f prime is greater than 0, right? So we're increasing here and here because our first derivative is greater than 0. Our second sentence is f of x is decreasing on 0 to 1 because the first derivative, f prime, is less than 0. We know that f of x is concave down on negative infinity to 0 because the second derivative is less than 0. We know that f of x is concave up on 0 to positive infinity because the second derivative is greater than 0. And those are coming from right here. Second derivative is positive. Here the second derivative is negative. And we know that there is a local minimum at 1, e because the first derivative changes sign. Okay, it changes from negative to positive at x equals 1. So that's right. That's right here. At x equals 1, it changes from negative to positive, so we know we've got a local minimum right there. And there are no points of inflection. All right, I'm going to stop this video because my dog needs to be let out. And I'll be back with one more example and then we're done.